this lab, we're going to be talking a lot about sort of random variance, how variance affects our data, and how we can select features in order to circumvent, bad data, so to speak. So once again, we're kind of trying to figure out how can we make the models we build better, okay? And how can we more efficiently build these AI models? Okay, so we can once again start with importing, our data set as per usual. So import load iris, and now we can import pandas as well. So as per usual, we do all of that. And then now we're going to kind of generate a new column to add to our iris data set in order to simulate some sort of feature selection process. So we're going to make a bad data set that's very low variance. Okay. So the way we're going to do that is we're going to import random. Okay. And then we're just going to create some random list that's called random. And we're going to loop 150 times because that's how many data points there are. That's how many features there are in the sample, as it were. And we're just going to generate a bunch of random numbers that are very low variance. So we're going to generate them between 65 and 65.2 for now. Okay. And then we're going to append them to this list that is correctly indented. And then we're going to put this into a column in our data frame. Okay. And then we're going to print it all out. So I'll give you a moment to type that out. Okay. And you should see it's something like 65.18, 65.13, 65.06, and everything is very, very tightly packed because there's 150 data points all across, 0.2. And the way we're going to add this to our data set is we're going to read in all of our data sets as per usual. So I can type. Okay. And then something, rename your columns to desired items. Okay. Or actually, I should have this. It's sepal length is column 1 or column 0, I guess. Then sepal width, then petal length, then petal width. Just to confirm. Because if you do it backwards, it's not necessarily going to affect the data because the data points are in the same columns, but it will confuse you a little bit. Okay. And then for the 5th column, we're going to add something called like temp. Okay, and then we're going to make that the random thing we just generated. And then we're going to look at the head of this data. So now you can see it has all of the data as per usual. And then it also has this temp column that's very, very low in variance. So all of the values are very much compressed. Okay. And that's fine. Okay, that might happen in our data set, but we know that that means bad. So what we want to do is we now want to evaluate this data and try and find out which one we should take out. Obviously, it's going to be temp, but let's assume for the sake of the lab that we don't know which one to take out. Okay. So what can we do to do that? Well, we can kind of plot a couple of our metrics. So let's go ahead and plot with matplotlib and with Seaborn. Let's do this following heat map. Okay, so when you create this heat map, you can see sepal. So the column or the rows are named, and then if you take that and kind of transpose it onto the top, that's how the columns are named as well. And you can see, oh, actually, it's at the bottom too. Yeah, great. So you can see kind of the correlations between the two, between each pair, as it were, of variables. You can see that in heat map. Okay. Fine, that's it. Fine, great. So now what we can do is from this, we can kind of go a bit closer and use a couple more tools in scikit-learn in order to actually select out, say this feature is really, really bad. Okay, so we can use this to kind of get an idea for what we're looking for, but there are other tools in sklearn itself that are going to let us like fully remove the data and actually, conduct these operations. So the first tool we're going to use is something called variance threshold. And this tool is going to remove any data that doesn't vary enough. So in other words, it's kind of useless and we just need to take it out. So okay, there we go. From sklearn.feature selection, which is what we're doing, right? We're doing feature selection. We're going to import something called the variance threshold. Okay. And let's say we want anything that's that has a variance threshold of 0.1 or above. So if it's less variance than 0.1, we're going to remove it. Okay. And then we're going to say the clean data is this filter dot, and then we're going to fit and transform on our original data, the data frame. Okay. Cool. Now, if we print out clean data, you can see that it doesn't give us back it doesn't give us back a pandas data frame, and that's kind of annoying because of everything we touched on in the last lab. So we're going to make this a clean data. We're going to make the clean data a data frame. We're going to get rid of this long array as well. Okay, so the way we're going to do that is very simple. It's as we've pretty much been doing the whole time. We're just going to do pd.dataframe and then make a data frame. Okay, and now you can see we can do all sorts of the same like head, info, describe, all of that on the data. And you'll notice our old labels really aren't there, which is okay because we can put it back. But the important thing is that you can see that there's only 4 columns once again. Okay, so our temp, our last like variable that was really low variance, that was taken out, which is good because it's very low variance, it's useless, we don't want it, right? So you can see the variance threshold, the dot fit transform removed the thing that we didn't want. Great. Okay, so that's one tool you can use. You can also use what's called the select k best tool. Okay, and this one is also relatively self-explanatory. It's going to select the k best features. K is a hyperparameter, so depending on how many features you have, if you have 100 features and you want to, maybe you need to use less RAM when you're computing, when you're building this AI model. So maybe you only want to use 50 features, or maybe you only want to use 25, or maybe you can afford to use like 75 or 80. That's something you kind of have to think about. Okay. But in this case, since we know that we only have one bad data column, we're just going to use, as you'll see, 4 later on. The first thing we want to do when we're selecting k-best is we want to run this chi-squared test on import it. And okay. Okay. Yes, this. Great. And now we need to actually access this. Okay, the way we're going to do that is, where is it? This. Okay, great. I did not need it. That is not correct. Okay. So given that I've forgotten how chi-squared works, we're gonna go ahead and look at the documentation. So, or maybe I think I imported the wrong one. Okay, let's try again. Ah, yes, okay. So this is a lesson in always importing from the correct library. It's not from SciPy, it's from sklearn. Interesting. It's been a long weekend. We'll chalk it up to that. But given that we have this chi-squared test of all 5 of our features, we can see most of them are like somewhere around an order of magnitude of like 0 or above. So the first one was around 11, then 3, then 116, interesting, and then 67, and then the last one is significantly smaller, or in the second case, significantly relatively larger. Okay. And so that kind of tells us that there's something interesting happening with the last feature, which we know is true. We put that feature in, right? So what we're gonna do is we're gonna import this select k-best from the same feature selection library. Oops. Okay, and we're gonna filter it out. We're gonna filter out the data set by doing a chi-squared test and selecting out the 4 best features. So once again, k here is a hyperparameter. You could put 3. If you put 5, it's not gonna get rid of anything, right? Because we have 5 features. And if you put 2, you're not gonna do much with 2 features, frankly. So, and then we'll just stick with 4 for now. But you can experiment if you have larger data sets with what changing this value of k does. Okay, so we're gonna run this. And then we need to run fit transform on this, on our data set. And then we can print out the head of this. But we have to convert it to a data frame first because it's an array. That's right. And then we can run head. Okay, and now once again, you can see it's removed the last column that we put in, which is the bad column we know. And it's given us the 4 best features, which in this case are the 4 expected features. Okay. And so that's kind of the second tool that you can use. So in the lab,